Hi guys, today I want to introduce you to a problem which looks very simple but can have very different answers, and you need to be able to recognize which technique to use. So this is integrating the reciprocal of a quadratic equation. I took the simplest form, but sometimes you could have some constant on the top, like maybe instead of, let's say, if you take the first problem, so where it's 1 over x square plus 2x plus 1, you might see it as maybe 5 over x square plus 2x plus 1. That's pretty much the same thing. But what matters is what is underneath, what is the reciprocal you're taking off. So here is x square plus 2x plus 1. The next problem is x square plus 2x plus 2. And the third one is x square plus 2x plus 3. You would, if you didn't know any better, you would think the answers would be somewhat similar. But far from it, you would be surprised how different they are, and why they are, and how to recognize it, and which formula to use is the thing that I want to focus on today. So, but also there is a nice little tool that you see the link that I showed there. So we're going to use this to calculate our integrals. So we won't be actually um, solving them, but we will use this tool to solve it, and then we'll understand why we're getting different answers. So this tool, if you're not familiar with, all you do is you go ahead and type in the formula and it gives you the answers. So it would give the right answer, but sometimes the method they use might not be the most optimum method. They might use a complicated method. So you got to watch out for that. But this is a very nice tool for you to practice for your exams. So let's do x square plus 2x plus 1. So we'll try this, deal with that later. So let's see what answer they came up with. So this is the answer they came up with, minus 1 over x plus 1 plus c. And that is a correct answer. We'll see how. So let me write down here what they gave us. Is equal to minus 1 over x plus 1 for plus c. So why is that the case? So you see this can be written as 1 over x plus 1 square dx, and if you do a u substitution, u is equal to x plus 1, and I'm sure you can solve it from there. So this would be the answer. So that's not too surprising, just that you have to make sure that you can identify that that's in fact x plus 1 square. So what about the next problem? What do you see if there is, you have some intuition as to what the answer might turn out to be before I actually try it out. Okay, so I'm going to change x square plus 2x plus 1 to x square plus 2x plus 2. Go. What did I get? I got arctan 2x plus 2 over 2 plus c. Well, this wasn't completely simplified. This would be arctan x plus 1 plus c, because if you cancel 2 on the denominator and the numerator. But that's pretty close. Actually, if you click on simplify, they would probably do that. So, but that's not important. So the main thing is the answer came out to be arctan. You know, arctan is nothing but tan inverse. So tan inverse x plus 1 plus c was the answer. Oops, sorry. So here, let me write this is equal to tan inverse x plus 1 plus c. So why is that? So how can I recognize this? So this one equal to same as the last what you see on the top, but x plus 1 square plus 1. Now if you again do a u substitution, you can see that this turns out to be 1 over 1 plus u square du. So you see that that is the formula for the tan inverse. So at the end, I will also talk about how you can recognize these things. But at least for now, you can see how drastically different the answers were. So now let's go to the last one. So we have x square plus 2x. Sorry, I wanted to do something else. So let's do uh, delete this one. I think I should just use this. Okay, that's much better. Let's get back to our pen. So the problem I want to do here is very annoying. Can't find this pen. So x square plus 3x plus 2. So now we would see a different answer. But I want to go ahead and write what this would be. So you can factor this into x plus 2 times x plus 1. Now this is a partial fraction. So the answers, let's see what answer we get. So I have the same thing. I changed 2x to 3x. Click go. So you see this ln of x plus 1 or modulus of x plus 1 minus ln of x plus 2 plus c. Two plus c. So you can actually also write this as ln of x plus 1 over x plus 2. But anyway, that's not important. So the main thing is that this has become a problem of partial fractions. You would have to decompose this by writing this as some kind of a over x plus 2 plus b over x plus 1 and solve that, figure out what a and b are and solve that integral. But so you can learn all those things as to how to solve them, but how do you actually recognize this? So one trick that you can use, I think I need to change the, okay, there you go. So here, think in terms of b square minus 4ac. So if I think of b square, quadratic equation b square minus 4ac, so what is b square minus 4ac here? This is 2 square minus 4 into 1 into 1. So that's equal to 0. So when that's the case, you know that you can convert it into a square, and then you would get the answer would be a simple formula that you can deal with. Now what about this? You have b square minus 4ac in this case is equal to 4 minus 4 into 2 into 1 is equal to negative 4. When it is negative, you would have the case of a tan inverse or arctan. And let's look at the last one. So the here b square minus 4ac is equal to 9 minus 4 into 2 into 1 is equal to 1, which is greater than 0. So in that case, you would have a situation of a factoring or you can always factor that and then do partial fractions and solve the problem. So hopefully this was helpful. So mainly I wanted to show the complexity in what looks like a very simple problem. So thank you. If you like the video, subscribe so that I can make more of them.